so the last couple days we've been working on lesson 34 with this implicit differentiation. We're going to follow the same three-step process today. We'll just do one extra thing at the end. We're actually trying to calculate the slope at the end of our question. Alyssa, what's the first step on an implicit differential question?
Find the differential each part.
Very good. So I do the differential of every single part of our question. Amelia, what's the second part on an implicit differential question? I divide. I'm trying to see, okay, what derivative am I trying to calculate? So I divide by what's in the denominator. And then Anna, what's the last step on an implicit differential question? Yeah, solve for what I'm actually trying to do in our question. Okay, so let's go ahead and begin with this problem. Go ahead and write that down for me. Now what we're going to do today is the exact same three-step process, but notice what the question says. It says find the slope. The definition of a derivative is a what? Slope. It's a slope, and that's what this question says, to find the slope of the tangent line that we have in our question. Once we come up with our formula for the implicit differential problem, we're then going to put in this point. Notice this point has an x and it also has a y, because all of our formulas that we've been calculating at the end have an x and a y in the question. Now, when it comes to a slope, and this I'm going to see if you can remember something, all of the derivative questions that we have faced up until this lesson, have they said dy over dx, or have they said dx over dy? Dy over dx. Notice this question does not say find dy over dx. But if they are asking you to do the slope, that is the format that we're going to follow, the dy over dx in our question. So if you need to make a note of that, if they just say find the slope, there's no format like we've seen on the previous questions, then you're going to do the dy over dx part of your question. Alright, so let's go ahead and tackle this problem together. We're going to follow the same three-step process that we found the last couple days together, because in order to calculate the derivative, in order to calculate the slope, we must have a derivative formula. Let's see here. So according to what we just reviewed, Colin, was the first step on an implicit differentiation question.
So find the derivative?
Yeah, so we're going to find the derivative, we're finding the differential of every individual piece here. Alyssa, what is the differential for x squared?
2x dx.
Very good, it is 2x dx. We do the derivative, we swing the exponent down to the front, leaving us with 1 at the top, then I have my dx. Colin, what is the differential for y squared?
2y dy.
Very good, it is 2y dy. And let's do the right side of our equation. What is the differential when it comes to 2, Amelia?
0.
It is just 0. Because it's a constant, we always have 0. There was no variable, so I don't have a dx or a dy at all in the question. Again, when my job is to calculate the slope, we're always going to follow the dy over dx format. Based on that, Anna, what must I divide by on my next step?
dx.
The dx. So all of the parts of our question are going to get divided by dx. All right, and Alyssa, can you tell me what the equation now says after I do that?
2x plus 2y dy over dx equals 0.
Oops. I was writing what you were saying. Equals what?
0.
Equals 0. Alright, so my job is to calculate this derivative, which is the dy over dx. So Amelia, what should I do next on this question?
Subtract 2x.
I'm going to subtract the 2x over, because that doesn't have the dy dx. And I'm going to write the fraction that's left, kind of like we did yesterday, where if that fraction was part of two terms, I factored it out to the front. So I'm going to write this as dy over dx. Then I'm going to put the 2y behind it. That's the exact same notation. You don't necessarily have to do that. I just like to see it with here's my derivative, there's the other part that I have in the fraction. The right side of the equation says negative because I subtracted it over. Colin, if I want to get that dy over dx by itself, what's the last step I need to take?
Divide by 2y.
Divide by 2y. And Anna, what is my formula then for the derivative dy over dx?
Negative 2x over 2y.
Okay, and actually that reduces in the question.
Wait, what?
That reduces, so what would it turn into?
Negative x over y.
There you go, negative x over y, because I can cancel out those 2's though, so I have negative x over y, and this is the formula that we're going to be actually following on the next 3 questions together. Everyone with me on how we calculated that formula? Alright, now before we actually answer the question that's on the screen, because we haven't quite answered the question yet, all that I've given is the derivative formula. The derivative allows me to calculate the slope, and that's what the question is going to ask us for in just a second. What kind of equation did I give you when it said x squared plus y squared equals 2? What is that? It's a circle. Remember we talked about earlier, if you had the x squared and the y squared and they were identical, that was a circle. Is a circle an example of a function? No, because it would fail the vertical line test. That's why when I go to calculate this derivative, when I'm calculating the slope, I have to have an ordered pair because there's 2 different locations that have the exact same x value. We looked at this on, I think it was Wednesday, together with our circle. This x value over here is the same x value down here, but they're going to have 2 different slopes because one's going down and one's going up in our question. They must give us a specific point like they have on this question when I don't have a function. So to finish this problem, actually to calculate the slope at the location 1, 1. Well, the definition of the derivative is the slope. The derivative that we just calculated said negative x over y. They gave me an ordered pair. An ordered pair is an x and a y. We're going to fill our ordered pair in. The x is 1, so it says negative 1. The y is also 1. Negative 1 divided by 1 is negative 1. And there is the slope. At that location on the circle, it has a negative slope in the question. That would be like in my picture, this line up here. Notice that line is going down, and things that are going down have a negative slope on our problem. Okay, everyone see kind of what we're going to be looking at today. After we calculate our derivative, we're then just going to put in the ordered pair that they give us. Right, we're actually going to use this exact same equation now for the next 2 questions together. So let's go ahead and take a look at those here. So if you will go ahead and write down what you see on the screen, and then we'll work through this example together. And then the second one will be very similar to this process. On this question, I have something about the tangent line. I have something about the slope. My job is to say, where is that slope going to happen? What we just did, we calculated a formula that would give us the slope. They gave us the point. We found the slope. Now we're going to see if we can reverse it. I know something about the slope. Can I figure out where that's going to occur on our question? Well, what do we know about slopes? The definition of a derivative is the slope. The derivative formula that we just did from the previous question said negative x over y. That is still the same derivative question that we're going to be following because this is the same equation that we just worked on together. Now, this is the key on this question, that my line is horizontal. What do we know about the slopes of horizontal lines that are going straight across from left to right? They have a slope of 0. That means the derivative, this derivative formula of negative x over y has to equal 0. If I have a fraction that is equal to 0, what part of that fraction is equal to 0? The x. So all that I currently know is that the x equals 0. Do I know anything about the y currently on my question? No. All I know is that the numerator has to be 0 because 0 divided by anything is 0 on the question. Well, the problem that they presented to us asked us to give us a point. Well, a point is an ordered pair. An ordered pair has an x, and it also has a y. At this point, I know that the x has to be 0. That's the only way that I would give a slope of 0 in the question. Any of you have any guess? If I know that the x is 0, how would I figure out the y on this question? Yes, Alyssa?
Would you just put 0 in your original equation?
You're going to put the 0 into the original equation. That original equation applies to the entire circle. So I'm still going to focus on the x squared plus y squared equals 2, but I know that the x had to be 0 because if the slope is 0, the numerator has to be 0, and that's where the x was located. So I see 0 squared plus y squared is equal to 2. Okay, everyone understand kind of what we're looking at here in the question? Alright, well, what's a 0 squared? 0. Okay, so I can ignore that part of the formula, and it just says y squared equals 2. If I wanted to calculate y, what's the last step that I need to take? I'm going to square root. What must I include when I square root on my question? A plus or a minus sign. So my y is positive or negative square root 2. Now I just need to present the answer in what it asked me to do. It asked me to give a point. Well, a point is an ordered pair, so I just need to write my answers as an ordered pair. What is the x in our ordered pair? It is 0. Now, how many y's did we just come up with from our work? 2, which means I'm going to give 2 different points in our question. The first order pair, I'm going to say is 0 positive square root 2. The second order pair is 0 negative square root 2 in our question. Does that make sense? What kind of equation did we have for x squared plus y squared equals 2? What was that? It was a circle. If you have a circle and you're looking for a tangent line that is horizontal, you have one that is up here, and you have one that is down there. It's hitting the circle twice, which is why you have 2 different ordered pairs on your question for this kind of tangent line. Okay. Any questions before we reverse it, and this time I want a vertical tangent in the question. Alrighty, so we go ahead and get that question up here using the exact same equation. This time I want the tangent to be a vertical line in our question. Well, we know in order to calculate the slope of the tangent line, we're using the derivative. The formula that we did 2 questions ago for the derivative said negative x over y. This question, I want this tangent line to be vertical. So I need to remember what is true about the slopes of vertical lines. We just said horizontal had a slope of 0. What is true about the slopes of vertical lines? They are undefined. Because vertical is going straight up and down. That means your rise over run. The question is not running. There's a 0 in the denominator, which means it's an undefined question. If I need this fraction to be undefined, what is the only thing that I currently know about this question? The y has to be 0. I don't know anything about the x yet. All I know is something divided by 0 would give me an undefined answer, and that means I have a vertical line in the question. I have half of the point, just like we did in the previous question. I'm going to put that information back into the equation, and we're going to calculate the x this time. So x squared plus 0 squared is equal to 2. I almost have an identical equation. This one just has x instead of y. So I have x is positive or negative square root 2, because we have the square root to solve for the x. Based on that work, Alyssa, what point or points would I give for my final answer?
Square root 2. Have a 0 and then negative square root 2 comes 0.
Very good. Once again, I have have two different points. If you think about a circle, where would I have a vertical line? There's one on the right side, there's one on the left side. I have two different locations on the question. The only thing that's different about them is the x, because one of them went left, one of them went right from the center, and that is in the x direction. The first one that we did, the horizontal line, well, to get to that horizontal line, I either had to go up or down, so it affected the y's that we had in our ordered units. Alright, everyone good so far? Alright, I got two last questions for us to finish up with today. Let's go ahead and take a look at this problem for you. It's the same equation that we just looked at, but it's a different differential this time. This one is dx over dt. What we just did was dy over dx. So we'll need to go through the differential equation again, and then using that, we'll answer the last question that I have on my next slide. We have on this kind of equation our implicit equation, because the y is not by itself. If I attempted to get y by itself, I don't have a unique equation, because it would have the plus and the minus sign, because we would have to square root to get the y by itself. We're going to follow our three-step implicit formula in order to come up with this derivative. Well, the first step, just like we did in the last question, was we calculated the differential of every single piece. So I start the exact same way with my 2x dx plus 2y dy equals 0. This question is asking me to find dx over dt. So what do I need to divide by common in order to calculate dx over dt?
You divide by dt.
I'm going to divide by dt, because that's what I have in the denominator for our derivative. Alright, so what do we have? Anything simplified from the first fraction? No. Okay, the differential on the top is dx, the differential on the bottom is dt, so those don't cancel out. I have 2x dx over dt. Second fraction, the same situation happens. Those differentials don't match. I can't cancel anything out there. So I have 2y dy over dt. The right side is still 0, because 0 divided by anything is 0. My job here, Amelia, is to solve for dx over dt. So what are we going to do next?
Subtract 2y dy over dt.
Very good. So move over the piece that doesn't have what we're looking for, because now we're just doing the algebraic solving. And I'm going to do this like I did on the previous question. What I'm looking for is within that fraction. So I'm going to yank it out to the front, the dx over dt. That would leave us with the 2x from the first fraction over here. And I'm going to do it the same way as well. I'm going to yank the differential out to the front. I really don't want to leave the differential within my fraction. I always want to see kind of a piece and then the differential behind it. And I'll fix that in just a second. But I'm going to follow the same format that I did on the left by moving the differential out to the front, and that cut me off. That over there says negative 2y inside that parenthesis. If I want to get dx over dt by itself, what's the last step that I need to take?
Divide by 2x.
Divide by 2x. Alright, so we can now write our derivative, dx over dt. And I'm going to write this now in kind of correct differential notation. In correct differential notation, we always kind of wrote the main part first, then we wrote any differential behind it. Well, the main part that we have, there's a negative 2y in the denominator, there's a 2x, or that's wrong. There's a negative 2y in the numerator, there's a 2x in the denominator, so those simplify to negative y over x. The differential, which is actually a derivative part on this question, I'm going to put behind that of dy over dt. There is my formula that's going to allow me to calculate the derivative of dx over dt. When it says that there are functions of time, then that's going to clue you that something over dt is going to show up in your question because the original problem did not have any t's on the original problem. Okay, everyone with me so far? Now I'm going to use that formula to answer the last question together. The last question, let's see if we can answer based on that formula. If I can get it to come up. If I know I want to calculate the dx over dt, there's my point. Again, to calculate a derivative in this lesson, they must give me a point. But notice what else they gave me is the dy over dt. Because the dy over dt showed up in the formula that we just came up with on the previous slide. The formula that we just came up with together for dx over dt said negative y over x dy over dt. That's why I like to write kind of that differential or derivative part as its own individual fraction, because that's even how they gave it to me within the question. Like we've seen so far this morning, we're going to fill in what it gives us about this question. The y that it states is 1. So I have negative 1. The x that it gives me is positive 1. What does it tell me about dy over dt? It says that that has a value of 7. We know two things side by side, we need to multiply. So what is the slope at this location of my question? It is negative 7. And there you go. All right, so any questions this morning about how to actually calculate the slope using the differential equations, using the derivatives that we've been writing together? All right, we got a couple minutes left here, actually 15 minutes left, so let's work on a couple questions together, and you guys should be able to finish these, and then you won't have to worry about any homework tonight. Let's go to page 186, and I would like you to try for me question 4. Let's start with number 4 here, see if we can correctly calculate the slope like we just learned.